In example 2, it says two cars travel the same distance. The first car travels at a rate of 40 miles per hour and reaches its destination in t hours. The second car travels at a rate of 55 miles per hour and reaches its destination 3 hours earlier than the first car. How long does it take for the first car to reach its destination? How long does it take for the second car to reach its destination? So we want to know, what is the variable and what does it represent? So the first thing we need to figure out is how long does it take for the first car to reach its destination. So let's use our variable t to equal the number of hours for the first car. Now in part B, we have to set up an equation to represent the situation. So we're comparing two different cars. So we're going to look at car 1 versus car 2. And it says over here that the cars travel the same exact distance. So that means car 1 and car 2 are going to be equal to each other. So now we've got to figure out car 1. And it says car 1, the first car travels at a rate of 40 miles per hour and reaches its destination in t hours. So we need to go back and remember our distance formula. So our distance formula is distance is equal to rate times the time. So if our distances are going to be equal, what we're looking at is the rate times the time for both of them. So if we take a look at the first car, 40 miles per hour, that's our rate. And t hours, that's our time. So we can put that down here. Rate times time would be 40 times our variable t. In car 2, it says the car travels at a rate of 55 miles per hour. So this 55, that's our rate. And it reaches its destination 3 hours earlier than the first car. So that's going to be our time. We're going to get that in there. So we know that the rate is 55. And then we have to multiply that by the time it takes. Well, our variable is in terms of the first car. And if the second car is 3 hours earlier, we're going to take the first car's time and subtract 3 from it. We want to make sure we have the same variable here and here. So now we can go into letter C and we can solve our equation. So we have 40t equal to 55 times t minus 3. And I'm going to distribute that 55 on the right-hand side to get 55t minus 165 after I distribute that 55 to both terms. Then if I look, I have my t's on the opposite side, so I have to get those together first. Since this one's all by itself, I'm going to move this one over to that side. And I can do that by subtracting. So I'm going to subtract 55t on the right, which means I'm going to subtract 55t on the left. And that's going to give me, on the left-hand side, negative 15t equal to negative 165. Let's move this up a little bit. And then what I need to do is I need to go ahead and divide. So I'm going to divide this side by negative 15, and I'll divide this side by negative 15. And I get my answer that t is equal to 11. So I can say the first car took 11 hours. And then I need to also find how long it took for the second car. Well, if the second car was 3 hours shorter, I'm just going to take that 11 and subtract 3. So the second car took 8 hours. If you have any questions, please raise your hand and I'll come around and help.